The forestry industry is a major export earner for New Zealand, but its workers face a high risk of injury or fatality. Accidents, particularly during tree felling and recovery, can be devastating in their impact. Concern about this led Dr. Richard Parker at Scion to develop a system that would keep forestry workers out of harm's way. Richard worked for a couple of years as a logger and is also a volunteer firefighter, so he understands what it's like to be on the end of a chainsaw.
I did a zoology degree here at Canterbury, and so I knew about the apes that could swing from tree to tree, and various snakes and other animals could move from tree to tree. So the thinking was maybe we could have a machine that could move from tree to tree. So that idea had been kicking around in my brain for a long time. And then when the Primary Growth Partnership developed with the industry and the Ministry for Primary Industries, there was a place where we could actually get going and do something. When I was sort of thinking through the idea, I needed to sort of work out, could this thing grip hold of a tree and what would it look like? So I built up a little balsa wood and syringe model, and so I can press the syringe here and it closes up and opens. So I made a model that had a couple of these on it on the end of a stick, effectively, and that was sort of the proof of concept. And then Scion supported me to get a colleague to build up a radio control version, which is a bit more sophisticated. Doesn't look very flash, but it does the job, and this is the radio control one, which effectively does the same thing. So this time it's attached to a tree at one end, and then the other end reaches out to grab the next tree. It's just a whole lot of servos, sort of radio controlled. So here it is, reaching out, trying to get to the next tree. And the machine can move around, and eventually it would move around the forest. The chainsaw would go on here, and that would cut down the next tree. So we just have a chainsaw at one end. And so once we got this device going, then we had something to show people outside the organisation, and through the Primary Growth Partnership and the Future Forest Research Program, we worked with Canterbury University. And so I took this model over to the university and showed them this thing working, and I think they were amused, and then thought, yeah, there's something here. And from there, we went on and built the bigger machine.
The project right now, where we have a first prototype, we are at the third generation of student groups. So the first one built the first prototype of the robot itself. The second student group built a cutting head, a cutting unit that we can attach to the gripper. And now the third generation, right now the students, they are focusing on two aspects of the project, namely the optimization and the semi-autonomous system or operation of the robot. We would like to see this project going further beyond the prototype and see this as a commercial product. I'm expecting it 5 to 8 years it would take, because what you see is a quarter scale size of the real thing with a reach of 2.5 meters, but we'd like to have it for, when it comes to cutting down trees, 8 meters or even a bit more. And that will probably have an altogether new design with the actuators not being electromagnetic but hydraulic and such things. So we're looking at project number 2, which happened in 2014, another student project. This whole unit is called the cutting unit or cutting head and goes below one of the gripper. So this chainsaw is driven by one motor unit, you see that here? And another motion is done by another motor that sits here that puts the forward and backward motion and cuts into the tree.
I don't think we want to move people from the bush. The bush is a nice place to be. Everyone doesn't want to sit in an office working. But the idea is to get the man or the woman away from the dangerous places in the bush, so they can still be operating this machine, but they're not right in under the tree. The excavator-based machines that are working on the steep terrain, they're a lot more capable than our machine because they're bigger and heavier. They can actually pick up felled trees and stack them so that they can be quickly extracted. Our machine will really only have the abilities of a tree faller with a chainsaw, so it'll fell the tree, but the advantage is that it should be smaller and lighter, and it doesn't actually touch the ground, so there's no ground disturbance, and it's another option for the forest industry, and it shouldn't be limited by the steepness of the terrain. So you're not running it on the little internal battery?
No, it runs faster and stuff if you run it off these ones.
We're just coming to the end of our primary growth partnership program, and so we'll be applying for more funding from some source in the coming year, but we're also keen to develop a proper commercial machine, so we'll be looking for commercial partners. We think it could be used throughout the in-forest activities of the industry, so you can sort of have some that fell trees, some that just measure trees, going from tree to tree, taking data. They might be able to thin, might be able to prune, might be able to take soil samples, all these different activities, just using the trees for locomotion. And maybe this tree-to-tree system can be developed to actually extract the trees as well, so then you've got no roads at all, which is a big cost that you don't have to incur.
This program was made with funding from New Zealand On Air.